Hi there, Richard here at the RPS project. Today I'm going to have a look at something quite simple. It's resistors in parallel. It's one of the basics, so I ought to really understand it properly. So let's get and have a look. Okay, here we are with a few resistors, a little breadboard, multimeter, and let's have a look at resistors in parallel. Now, what am I talking about? A resistor in parallel. Well, 1, 2, yeah, you can tell didn't go to art school. Three resistors. We got our plus voltage or signal, whatever it is, but for the sake of ease we're just going to talk about DC voltage. Okay, on this side 0 volts or ground. Yeah, that you can read my writing. I always say if you've got terrible writing you should have been a doctor. Yeah, right. 3 resistors, the voltage comes in and current, and then it splits off and goes through all 3. So let's have a look at what calculations and what effect that's going to have by having more than one resistor in parallel. Now the thing with resistors in parallel is, what is the resistance? What's the resistance going to be if I've got more than one resistor? Now in series you just add them up, but in parallel there's this odd paradox that where if you have 2 resistors the total resistance is less than the resistance of either one of the resistors. So that's annoyingly odd, but let's have a look at the equation for that. Let's say I've got 2 resistors. Apparently it's 1 over R total equals 1 over R1 plus 1 over R2. I've got 2 resistors. That supposedly is the equation. I have seen it written a little differently, like this: 1 over 1 over R1 plus 1 over R2. But I'm pretty sure that that is the same as doing that. So let's start off with something like a couple of resistors. We're going to do something where, I don't know, 1k, the obligatory 1000 ohm resistor used everywhere. Now if I've got 2 of these, let's do it this way. I've got 2 of these, so I've got plus, and then it doesn't have to be 0, this could be within a circuit, so that could be another point where something else, another part of the circuit is down here. So it doesn't have to be plus volts and 0, could be anywhere within a circuit really. But we've got 2 and we've got 1k, 1k. So according to that equation I'd be saying that, let's do these parts first in the equation. I've got 1 divided by 1000 plus 1 divided by 1000. So let's calculate what that's going to be. 1 divided by 1000 equals, so that equals 0.001. Simple. and the other one's going to be the same, 0.001, and then we're going to add those together, so that's going to be 0.001 plus 0.001, simple, 0.002. Now the next thing we've got to do, if you remember the equation, is that our total is 1 divided by our total. So now we've got the total, we've got to have 1 divided by 0.002. So 1 divided by 0.2 equals 500. It's 500 ohms. That is very simple. Can't go far wrong with that, can you? So, I mean, what's the point in that? I suppose one of the things is to understand the difference in that if you've got two different resistors in there. Okay, let's do it with two different resistors. Let's say I've got a 1k, I don't know, let's go with something big, I suppose, 47k. Now I know 47k is a standard resistance, you can get that. So start off with the equation. We've got R1 over RT total equals 1 over R1 plus 1 over R2. We'll call that R1 and that R2. So I'm going to say that I've got 1 divided by 1000 plus 1 divided by 47,000. So we know that this equals 0.001 plus, and it should be fairly simple to work out in the old grey matter, but let's do it on here anyway. 1 divided by 1 divided by 47000 equals 0.00002. Well, it's 21276, but what we'll do is we'll just round it up, scratch out the last bit and call it the 2. So add those together, 0.001 plus 0.0002 gives me 0.00102. Now, as I said, to finish this off, 1 divided by R total. So 1 divided by 0.00102. 1 divided by 0.0102 equals 980 ohms. Something you may have already quickly noticed, as I did when I first looked at this, is that resistance is smaller than that resistance. So the total resistance was always less than the smallest resistor that you have in the circuit. So even if you have a 10 meg resistor, if you have the other resistor being, let's say, 10 ohms, your total resistance will still be below 10 ohms. That's the way they work. Now the other thing is that if I've got resistors of the same value, I can just divide it by the divide that value by the number of resistors. That is, if I've got two 1000 ohm resistors, that's 2. If I wanted to know the total resistance, I can actually just take that 1000 and divide it by 2. Of course we know equals 500 if all the values are the same. So you could actually have, I don't know, 4 resistors, 4 1000 ohm resistors. What's that going to be? It's going to be 250 ohm, because it's going to split it evenly through all 4 resistors. Straightforward. Now, as I've just shown with the values for different values, it still works. You can, as I say, have more resistors. You could have 1000 ohm or 47,000. You could have a what else can I put in there? 3,300 ohm, and let's say let's do something really small, like a 220 ohm resistor. So we got a 1k, 47k, 3k3, and a 220 R resistor. So that's a whole bunch of resistors. What is the total resistance going to be? Well, from the equation, 1 over R total equals 1 over R1 plus 1 over R2, and etc. for as many resistors as you want. So we'll start with 1 over 1000 plus 1 over 47,000 plus 1 over 3,300 plus 1 over 220. So let's work these out first. And that 1 divided by 1000, that's the 0.001. 1 divided by 47,000 is 0.0002 plus 1 divided by 3,300 is 0.003 plus 1 divided by 220 is 0.0045. So just add them all up together. Do that quickly, get it done. That equals 0.00582. But we're not finished, are we? Because we know that we've got to take that to get our total. It's 1 over our total, so 1 divided by 0.00582. 0.00582. 1 divided by 0.00582. I get 170, we'll round it up slightly, 72 ohms. Correct, number 2 probably. So as you can see, again, even though we had 1,000, 1k, 1,047k, 3k3 and a 220 ohm resistor, our total resistance still works out to be less than the overall resistance of any of the individual resistances. Very simple. Now, there's another way of doing this. If, like, you'll quite often have 2 resistors, and there is another little equation that you can use. R total equals R R1 times by R2 divided by R1 plus R2. This is much simpler. Well, to me it is, because if you've only got two, you can quite quickly plug in this in one go on here on the calculator. So let's say R1 equals, let's do something really small. Let's do it 1.2 ohm, and R2 equals 1.3 ohms. Almost exactly the same, but not quite. There's a slight variation there and there. They're not quite exactly the same resistance. Now, on my calculator, if I do it right, I can say that R total is, I have to put my brackets in, going to be 1.2 times by 1.3, close brackets, divided by brackets R1, which is 1.2, plus 1.3, close brackets, equals, that equals 0.624 ohms. Tiny little resistance there. I did that just because it's quicker and easier to do maths on a small number than it is a larger number. Excuse me. But as you can see, if you know that equation, you've got two resistors. It's very quick if you know how your calculator works to very quickly plug that in and get a result. And that says 0.624 ohms. Now, obviously, if you're working in much larger numbers, let's say that was 1K2 and 1K3, it wouldn't be, you know, obviously it's a factor of that by 1,000. So is that 662, is it? Don't know, go do the maths and find out. But there you go, that's very, very simple. I mean, I suppose I could take this lot. I've got, let's do these resistors here. These are 1K resistors. I've got 4 of them. And on this breadboard they're now all in parallel, so let's find that. Now they're 1K, so I'm thinking I'll put it on the 2K range. Let's find out if I put this across there what I'm going to get. 250 ohm, because there's 4 of them. 1000 divided by 4, 250 ohm. Even though, and I'll prove it to you, take an individual one, 1000 ohm. There you go. So it does work. And the other thing is, if I take this 1000 ohm and something like this one, which is actually a 10,000, a 10k ohm, and we'll just prove that by measuring it. See, just under 10k, it's a 1% tolerance. I'll count that as a 10k. And I've got a 1k there. I'll bung these in. Bent the legs everywhere. Let's get it in. So this should actually be, even though it's a 10k, the total resistance is going to be less. See what it tells us, what it is. Telling us that it's 900. 900 ohms. There you go. And I could calculate that very quickly using that equation. There you go. Resistors in parallel. It's that simple. Catch you next time.